What if the story of intelligence on this planet doesn't begin with us? You're about to hear a tale of how time erases civilizations completely, about why we might not be the first to gaze at these stars and wonder about our place in the cosmos, and about what beings could have built, thought, and created long before the first human learned to kindle fire. Close your eyes for a moment. Imagine yourself standing atop a mountain. You look down and see layers of rock plunging into the abyss for kilometers. Red sandstone, gray limestone, black basalt. Each layer isn't just stone. It's a page in a book that's been written over 4.5 billion years. 4.5 billion. Try to feel that number. Not just understand it intellectually, but truly sense it. If you started counting seconds from Earth's birth to today, never stopping for even a moment, you'd need more time than humanity itself has existed just to count to the first billion. Now multiply that by 4.5. All of recorded human history, from the first Sumerian tablets to this very day, spans the last 6,000 years. 6,000 out of 4.5 billion. Convert that to percentages, and you get 0.0013% of the planet's age. We exist in the final instant of its life, in the last fraction of a second on the cosmic clock. And here's the question that should make you pause. What happened during the remaining 99.9987%? We know about dinosaurs. Write in the comments where you're watching from. If you want more stories like this, mysteries and secrets of our world to listen to at night, hit like and subscribe. And we continue. They dominated for 165 million years. That's 27,000 times longer than human civilization has existed. But even the age of dinosaurs represents only the last 3.5% of Earth's history. What came before them? Who lived during those unimaginably long periods about which we know almost nothing? Paleontologists will tell you. Simple creatures, primitive life, slow evolution from single-celled to multi-celled organisms, from invertebrates to vertebrates. A straight line from bacterium to human. A beautiful, simple, comprehensible story. But is this truly the only possible story? Scotland's National Museum houses a fossil that has haunted scientists for half a century. This creature is called Tully monstrum, or the Tully monster. It lived 300 million years ago in ancient swamps across what's now Illinois. It had a soft body about 35 centimeters long, a long proboscis with claws at the end, and eyes on stalks positioned along the sides of its body. Sound strange? That's not even the most interesting part. The most interesting part is that scientists still cannot determine what type of animal it was. Not what species or family, but what type. It's like finding a creature and being unable to figure out whether it's a mammal, reptile, fish, or something entirely different. The Tully monster doesn't fit into any known category. It simply exists. A unique evolutionary experiment that appeared, lived millions of years, and vanished without leaving descendants. And it's not alone. The Cambrian period, which began 541 million years ago, is often called the time of the greatest evolutionary explosion in planetary history. In just 25 million years, a blink by geological standards, practically all known animal types appeared, plus numerous other types that went extinct without leaving a trace. In the Burgess Shale of Canada's Rocky Mountain system, paleontologists find fossils of creatures that look like illustrations from Lovecraft's books. Hallucigenia, with spikes on its back and stilt-like legs. Opabinia, with 5 eyes and a grasping proboscis. Anomalocaris, a 2-meter predator with a circular mouth studded with teeth and segmented limbs. These were real animals. They lived, hunted, reproduced. They were as real as lions and elephants today. But then they disappeared completely, and other life forms took their place, more familiar to us. Trilobites, ancient arthropods, the first fish, ancestors of everything we see today. But here's what makes you think. These strange Cambrian creatures lived 500 million years ago. We've had another 499 million years after them. That's time 83,000 times longer than all of human civilization. Over these half-billion years, evolution experimented billions of times, created countless life forms, tested endless combinations of genes, morphologies, behavioral patterns. And we're certain that throughout all this time, intelligence appeared only once. Only in us. Only in the last few 100,000 years. Look at this from another angle. Eyes evolved independently at least 40 times. 40. Insects have one eye design, cephalopods another, vertebrates a third. Evolution arrived at the same solution again and again. Seeing is useful for survival. Wings appeared independently 4 times, in insects, birds, bats, and pterosaurs. Each time differently, but each time functional. Flying is useful, so evolution invented flight over and over. Social behavior arose hundreds of times. Ants live in colonies with division of labor. Bees build complex hierarchical societies. Wolves hunt in packs with coordinated tactics. Dolphins communicate and teach their young cultural traditions. Elephants remember their dead and conduct something resembling mourning ceremonies. Evolution doesn't invent something once and stop. It experiments, tries different paths to the same solution. And if a solution works, it appears again and again. So why should intelligence be the exception? Why should the ability to think abstractly, plan for the future, use tools, transmit knowledge through generations, be so unique that it appeared only once in the entire 4.5 billion year history of the planet? Doesn't that seem suspicious to you? Let's examine a specific example. Troodon, a small dinosaur that lived about 75 million years ago. Body length approximately 2 meters, weight around 50 kilograms. It moved on 2 legs and had developed 4 limbs with grasping claws. But the most interesting part is its brain. Troodon possessed one of the highest brain-to-body mass ratios among all known dinosaurs. Its encephalization quotient was comparable to modern ostriches and some primates. It had large eyes, indicating good vision and possibly a nocturnal lifestyle. Its teeth were small, suggesting omnivory and the ability to adapt to different food sources. But the most astonishing aspect is the discoveries made by paleontologist John Ostrom in the 70s. He found fossils of several troodons that died together, indicating social behavior. They hunted in packs, coordinated their actions, possibly cared for injured group members. One of Troodon's discoverers, Dale Russell, went further. In 1982, he published a provocative article asking, what if dinosaurs hadn't gone extinct? What if Troodons, or their descendants, had another 65 million years to evolve? Russell created a model of a hypothetical dinosauroid, an upright creature about 1.5 meters tall, with an enlarged skull, binocular vision, and 3-fingered manipulative limbs. A being that could develop intelligence comparable to human intelligence. The scientific community criticized his work. Too speculative, they said, too anthropocentric. Evolution doesn't work along predetermined trajectories. And they were right. Evolution truly doesn't move toward any goal. It simply adapts to current conditions. There's no guarantee that Troodons would have developed high intelligence even if they hadn't gone extinct. But here's what the critics missed. The question wasn't whether Troodons specifically would develop intelligence. The question was whether anyone would develop intelligence if dinosaurs had another 65 million years. And the answer to that question is possibly yes, because the evolutionary pressures that led to the development of human intelligence, climate change, competition for resources, the need to adapt to new conditions, these aren't unique circumstances. They're patterns that repeated again and again throughout Earth's history. Dinosaurs ruled the planet for 165 million years. That's a colossal period of time. During these 165 million years, the climate changed repeatedly. Continents drifted, sea levels rose and fell, minor mass extinctions occurred, new predators and new prey species appeared. Evolutionary pressure was constant, and in response to this pressure, dinosaurs became increasingly diverse, increasingly specialized, increasingly complex. Some became giants, sauropods, the longest animals ever to walk the earth. Argentinosaurus weighed possibly up to 100 tons. Its heart had to pump blood to the height of a 9-story building to deliver oxygen to its brain. Others became predators of incredible efficiency. Tyrannosaurus rex, with a bite more powerful than any modern animal. Velociraptor, with sickle-shaped claws and possibly proto-feathers. Others developed defensive mechanisms. Ankylosaurus, with an armored body and a club on its tail. Stegosaurus, with rows of plates along its back that could regulate body temperature or serve for social signaling. But what about intelligence? What about the ability to think? We have evidence that some dinosaurs were far smarter than we thought. Maiasaura, good mother lizard, built nests and cared for its offspring, requiring complex behavior. Troodontids, to which Troodon belongs, show signs of social organization. Some theropods possibly used primitive tools, stones for breaking eggs or shells. This isn't human-level intelligence, of course not. Roughly the size of a modern human, perhaps slightly smaller. Bipedal, long manipulative forelimbs with opposable digits, binocular vision, a brain the size of a chimpanzee's or early hominids. They live in groups of 20 to 50 individuals. They hunt coordinately, surrounding prey and using primitive weapons, sharpened sticks, stones. They build simple shelters from branches and leaves. They use fire, discovered after a lightning strike, for protection from predators and possibly for cooking food. They have language, not as complex as modern human language, but sufficient for transmitting information about prey location, dangers, places with good resources. Young individuals learn from elders. Knowledge passes through generations. These are the beginnings of culture. This is the start of civilization. Give this species another 1,000,000 years, another 10 million. Where could they have gone? Maybe they would have learned to process stone, creating more effective tools. Maybe they would have started building permanent settlements near water sources. Maybe they would have developed primitive agriculture, cultivating plants and domesticating other dinosaurs. Or maybe not. Maybe they encountered an ecological crisis. The climate changed. Their main food sources disappeared. A new predator started hunting them. Disease decimated the population. Evolution doesn't guarantee success. Most species die. That's the norm, not the exception. But here's what's important. They had the opportunity. They had a chance. And now the question that should haunt you: if they existed, if such an intelligent reptile truly lived 90 million years ago, how would we know about it today? Where would the evidence be? The answer to this question is simultaneously simple and terrifying. Most likely, nowhere. Time is the greatest destroyer that exists in the universe. It erases everything, absolutely everything, with patience impossible to imagine. Let's conduct an experiment. Right now, at this very moment, all humanity disappears, simply ceases to exist. What happens to our cities, our roads, our skyscrapers and bridges? The first year would seem almost normal. Buildings stand, cars rust on roads, planes remain on runways. But without people maintaining infrastructure, a slow process of destruction begins. After 10 years, the picture changes dramatically. Roofs leak, letting in rainwater. Freeze-thaw cycles destroy concrete. Tree roots crack foundations. Vegetation covers highways. Cities begin to resemble ruins. After 100 years, most wooden structures have rotted. Metal has rusted. Glass facades of skyscrapers have collapsed, turning into piles of shards. Forests return, covering territories that were once megacities. After 1,000 years, only the most massive stone structures remain above the surface. Yes, the Egyptian pyramids will still stand. Yes, some dams and tunnels will survive. But 99% of our civilization has already disappeared. After 10,000 years, even these last traces begin to fade. Wind, water, vegetation do their work. Stones crumble, metals oxidize and become part of the soil. After 100,000 years, only the most resilient materials in the most protected places remain from our civilization. Some plastics may survive. Somewhere deep underground, metal objects may lie, transformed into mineral concretions. But discovering them accidentally is virtually impossible. After 1,000,000 years, even these traces become almost indistinguishable. Plastic has decomposed into molecules. Concrete has crumbled to dust. Metals have mixed with natural ores. What remains? A thin layer in the geological record with an unusual concentration of certain elements. An anomaly in carbon isotope composition. A strange distribution of certain chemical compounds. A geologist of the future studying this layer might notice something unusual, but would they understand what it means? Or would they simply attribute the anomaly to some natural phenomenon? An unusual volcanic eruption, a rare meteor shower, a climate anomaly. Now add more time. Not 1,000,000 years, but 10 million, 50, 90. During this time, the continents themselves will change. Mountains that stood when our civilization existed will be worn down by erosion to their foundations. New mountains will rise in their place. Oceans will open and close. Tectonic plates will shift, plunging entire regions into Earth's mantle, where they'll melt and become part of volcanic activity somewhere else. After 90 million years, absolutely nothing would remain of our civilization that could be found accidentally. No ruins, no artifacts, no obvious signs. Only very thin, very specific chemical and geological anomalies that would need to be deliberately sought, knowing in advance what to look for. And here's where the true depth of the problem manifests. If we, with our advanced technology, with our skyscrapers and nuclear reactors, with our plastics and alloys, would leave such a faint trace after 90 million years, how can we expect to find traces of a civilization that existed exactly 90 million years ago, or 200 million, or more? Perhaps they were here. Perhaps intelligent species have already risen and fallen on Earth, species we'll never know about. Not because they weren't here, but because time is too good at keeping secrets. In 2018, two scientists published a work that made the scientific community contemplate the impossible. Gavin Schmidt, a climatologist from NASA, and Adam Frank, an astrophysicist from the University of Rochester, asked a simple question. If an industrial civilization existed on Earth millions of years ago, could we detect its traces? They called this the Silurian hypothesis, a reference to a British science fiction series about intelligent reptiles. But behind the playful name lay serious science. Schmidt and Frank weren't claiming such a civilization existed. They were asking a methodological question. What would the evidence look like if it had been here? And their conclusions turned out to be troubling. Even our own civilization, which has so radically altered the planet, could become almost invisible in the geological record after sufficient time. Yes, we're leaving traces. Altered atmospheric composition, plastic in the oceans, radioactive isotopes from nuclear tests. But how long will these traces last? Plastic degrades, slowly, but it degrades. After millions of years, most of it will have turned into dispersed organic molecules. Atmospheric changes will be smoothed out by natural processes. Radioactive isotopes will decay. The half-life of cesium-137 is 30 years. Strontium-90, about 29 years. Plutonium-239 is much longer, 24,000 years. But even it will eventually disappear. What remains? Perhaps the most enduring trace would be a change in carbon isotope composition. When we burn fossil fuels, coal, oil, gas, we release carbon into the atmosphere that was buried millions of years ago. This ancient carbon has a slightly different ratio of carbon-12 to carbon-13 isotopes compared to carbon currently circulating in the biosphere. A sharp change in this ratio would leave a mark in geological layers. A future geologist millions of years from now might notice this anomaly. A sudden spike in a certain type of carbon. But what would they think about it? Here's the problem. Nature also creates anomalies, and some of them look very similar to what we create. 56 million years ago, an event occurred that scientists call the Paleocene-Eocene thermal maximum. Over a very short period by geological standards, the planet's temperature rose by 5 to 8 degrees Celsius. Mass extinction began in the oceans, and carbon traces in rocks from that time show a sharp change, exactly like what we're observing today from burning fossil fuels. What caused this ancient event? Most scientists believe it was natural causes. A massive release of methane from ocean sediments, triggered by volcanic activity. Methane is a greenhouse gas 25 times more powerful than carbon dioxide. Its release into the atmosphere caused rapid warming. This is the standard explanation, logical, based on geological data. But imagine an alternative for a second. What if 56 million years ago, an industrial civilization existed on Earth? What if they too burned fuel, changed the atmosphere, caused global warming? What if a climate crisis destroyed them along with most other species? How would this look in the geological record? Exactly the same, absolutely indistinguishable from the natural Paleocene-Eocene maximum. We have no other evidence of that hypothetical civilization. No artifacts, no structures, nothing concrete. Therefore, the standard natural explanation remains most probable. But the key word here is probable, not certain, not proven, simply more probable based on what we know. And that's the essence of the Silurian hypothesis. It's not about whether they actually were here. It's about the fact that we cannot be completely certain. Our methods for detecting civilization in the deep past are too imperfect. The geological record is too fragmented. Time has erased too much. This is a challenge to our certainty, a reminder that absence of evidence isn't always evidence of absence, especially when dealing with timescales of tens or hundreds of millions of years. Let's dig deeper. What specifically are we looking for when searching for traces of an ancient civilization? First, and most obvious, physical artifacts. Tools, weapons, ornaments, building parts, the things archaeologists find when studying ancient human cultures. The problem is that such artifacts survive only under exceptional conditions. Metal rusts, wood rots, fabric disintegrates. Even stone eventually breaks down. The oldest known stone tools made by our ancestors date to approximately 3.3 million years ago. They were found in Kenya in 2015. These are simple stone flakes used for butchering meat or processing plants. 3.3 million years sounds impressive, but it's a drop in the ocean compared to the age of dinosaurs, who lived from 230 to 66 million years ago. That's 70 times older than the most ancient human tools. And these ancient tools survived only because they're stone, lay in very dry conditions, and were buried quickly, protected from erosion. This is the exception, not the rule. Most artifacts disappear much faster. After a few thousand years, let alone millions, nothing remains of them. So expecting to find something like a dinosauroid axe or reptilian spear would be naive. Even if they existed, they've long since turned to dust. Second, structures. Buildings, roads, bridges, dams, large-scale landscape changes. Here the situation is slightly better. Massive stone constructions can survive millions of years under the right conditions. But under the right conditions is the key caveat. Most ancient structures decay. Erosion does its work. Earthquakes topple buildings, floods wash away foundations, vegetation splits stones with roots, tectonic activity deforms and remelts rocks. Moreover, we've excavated only a tiny fraction of Earth's surface. Archaeologists estimate that less than 1% of all ancient human settlements have been discovered, and these are settlements only a few thousand years old, at accessible depths. What about structures 100 million years old? They'd be buried under kilometers of sedimentary rock, deformed by geological processes beyond recognition, or completely destroyed by subduction of tectonic plates. The chance of accidentally stumbling upon such a structure is virtually zero. Third, chemical traces. And here's where it gets interesting. We've already mentioned carbon isotopes, but there are other markers. For example, elevated concentrations of certain metals. Our civilization mines and processes enormous quantities of copper, zinc, lead, rare earth elements. These metals enter the environment through pollution. In sedimentary layers from our era, future geologists will find abnormally high concentrations of these elements. This would be a clear sign of industrial activity. But after millions of years, these concentrations will wash out. Metals will disperse, mix with natural ores, be recycled through geological cycles. The signal will grow weaker and weaker until it's lost in background noise. The same with plastic. We produce about 400 million tons of plastic every year. Most ends up in the environment. Microplastic is now found everywhere, in soil, in oceans, in Arctic ice, even in our bodies. Plastic is persistent. Some types can survive tens of thousands of years. Over time, it fragments into increasingly smaller particles, but doesn't completely disappear. Theoretically, a thin layer rich in hydrocarbon polymers with a specific molecular structure could remain in the geological record. But after 50 or 100 million years, under the pressure and temperature of Earth's deep layers, plastic polymers would most likely decompose and reorganize. The layer might simply become a layer with unusual chemical composition that would be difficult to distinguish from natural organic deposits. And radioactive isotopes? They're the most interesting because they don't occur naturally in significant quantities. Plutonium-239, for example, virtually doesn't exist naturally. Its presence in rocks unambiguously indicates artificial origin. But the half-life of plutonium-239 is 24,000 years. Sounds long, but it's nothing on geological scales. After 1 million years, only negligible traces remain. After 10 million, practically nothing. After 90 million, absolutely nothing. So even this perfect marker of technological civilization only works for the relatively recent past. So it's a hopeless situation? If an ancient civilization existed tens of millions of years ago, are we doomed never to know about it? Not quite. There's one more type of trace we haven't discussed yet. Biological. Fossils. If an intelligent species existed millions of years ago, where are their bones? Where are their skeletons in paleontology museums? Good question. And the answer shows just how rare and precious fossils truly are. Fossilization is an extremely rare event. For a bone to become a fossil, a whole series of conditions must align. The animal must die in the right place, near water, in a swamp, with active sediment accumulation. Its body must be quickly buried before it decomposes or is eaten by scavengers. The sediments must contain the right minerals to replace organic material. The layer with the fossil must avoid erosion, tectonic deformation, metamorphism. And after all that, someone must accidentally find this fossil, which might be buried at depth, hidden in a remote location, fragmented beyond recognition. Paleontologists estimate we've found fossils of less than 0.01% of all species that ever existed. 99.99% of species in Earth's history left no fossil remains whatsoever. They lived, reproduced, died, and disappeared completely, as if they'd never been here. Now imagine an intelligent species, relatively rare because large intelligent animals usually aren't numerous, living perhaps in specific ecological niches that don't favor fossilization, for example, in mountainous or forested regions where erosion is active and bones quickly break down. The chance of finding their fossils would be incredibly small. Moreover, even if we found their bones, would we recognize that they were intelligent? Think about it. What in a human skeleton indicates our intelligence? The skull is large, yes, but there are dinosaurs with heads bigger than a human torso, and they weren't intelligent. Bipedalism? Many dinosaurs walked on 2 legs. Manipulative forelimbs? Velociraptors had dexterous 3-fingered claws with opposable digits. Intelligence doesn't leave unambiguous traces in anatomy. Of course, a large brain relative to body size is a good indicator, but we can't directly measure brain size from a fossil, only cranial cavity volume. And it doesn't always correlate directly with intelligence. So even if a paleontologist found a skeleton of an ancient dinosauroid, they might simply classify it as another species of troodontid or dromaeosaurid. Note the unusually large cranial cavity, the manipulative limbs, but not make the next leap to suppose that this creature was intelligent. Without context, without artifacts near the bones, without traces of culture, a skeleton is just a skeleton. Another extinct species in a long list of extinct species. And here we arrive at a conceptual problem that's perhaps the most important of all. We're searching for a civilization that looks like ours. Cities of stone and metal, roads and bridges, agriculture and industry, electricity and machines. But this is our path. The path of primates with grasping hands and binocular vision. The path of terrestrial mammals who can kindle fire and process metals. What if another civilization took a completely different path? Imagine an intelligent species that evolved in the ocean. Dolphins and whales already demonstrate impressive intelligence. They live in complex social groups, communicate using sounds, transmit cultural knowledge through generations. Some dolphin species use tools, sponges to protect their rostrum when searching for food on the bottom. What if in the past, an oceanic species went further, developed true intelligence, the ability for abstract thought, for planning? They wouldn't build buildings. In water, that's meaningless. They wouldn't kindle fire. Underwater, that's impossible. The entire development path through metallurgy, the Bronze Age, the Iron Age, would be closed to them. But there are other paths to complex technology. Acoustics, using sound for navigation, communication, even for manipulating the environment. Biotechnology, cultivating and modifying living organisms to create tools, using currents and temperature gradients as energy sources. Such a civilization would be radically different from ours. Their technology wouldn't look like technology in our understanding. It would be organic, integrated into the natural environment. And if such a civilization existed in an ocean that later disappeared due to continental movement, all traces would be destroyed. The ocean floor is unstable. It's constantly renewed through the process of plate tectonics. On the ocean floor are mid-ocean ridges, places where new Earth's crust forms from rising magma. This crust slowly moves away from the ridge at a rate of several centimeters per year. This is called spreading. Eventually, after tens of millions of years, oceanic crust reaches the edge of a continental plate, and here, subduction occurs. Denser oceanic crust plunges beneath lighter continental crust, being dragged back into Earth's mantle, where it melts and is recycled. The entire process takes approximately 200 million years. This means the ocean floor completely renews every 200 million years. The most ancient ocean floor that exists today dates to approximately 280 million years ago and is located in the Mediterranean Sea. Everything older has disappeared, remelted, destroyed without trace. So, if an oceanic civilization existed 300 million years ago, or 400, the place where they lived no longer exists. It was dragged into the planet's interior and recycled into new magma that later emerged at the surface somewhere else as volcanic lava. This isn't conspiracy theory. This is simply geology. This is how our planet works. Or imagine a terrestrial civilization, but not industrial. A species that lived in harmony with its environment, didn't mine fossil fuels, didn't build massive stone cities, didn't pollute the atmosphere. Sounds utopian, perhaps, but this doesn't necessarily mean a more primitive civilization, just a different one. They could have used renewable energy, solar, wind, geothermal, long before we invented these technologies. They could have built from biodegradable materials, wood, plant fibers, which don't leave long-term traces. They could have practiced permaculture instead of destructive agriculture, living among the forest rather than cutting it down. Such a civilization could have existed millions of years without leaving the crude geological footprint we're leaving. They'd be almost invisible in the stone record. And this leads us to a troubling thought. Maybe they were smarter than us. Maybe the true measure of an advanced civilization isn't how many traces it leaves, but how few. We're proud of our skyscrapers and highways, our factories and power plants, but what if all this is a sign of underdevelopment, not maturity? What if a truly advanced civilization would learn to live without destroying their planet? This is speculation, of course, but it forces us to reconsider our assumptions about what a civilization should look like. Now let's talk about mass extinctions. Because if ancient civilizations existed, mass extinctions are the most likely way they ended. Over the last 500 million years, 5 major mass extinctions have occurred. Scientists call them the Big Five. Each destroyed a significant portion of life on the planet, from 70 to 96% of all species. The fifth and most famous is the Cretaceous-Paleogene extinction, 66 million years ago. An asteroid approximately 10 kilometers in diameter slammed into what is now the Yucatan Peninsula in Mexico. The impact energy was equivalent to billions of nuclear bombs. The consequences were catastrophic. Tsunamis hundreds of meters high rolled across coastlines. Rock blasted into the atmosphere created a firestorm worldwide. Fires engulfed continents. Smoke and ash blocked the sun for months, possibly years. Temperature plummeted sharply. Photosynthesis stopped. Food chains collapsed. Dinosaurs, who had dominated for more than 150 million years, disappeared within a few millennia. 3/4 of all species on the planet went extinct. Only the smallest, most adaptable survived. Mammals the size of rats, some birds, crocodiles, and turtles. In the oceans, fish, sharks, some marine reptiles. It was terrible, but not the most terrible. 252 million years ago came the Permian-Triassic extinction. It's sometimes called the Great Dying, and the name is deserved. 96% of all marine species perished. 70% of terrestrial vertebrates. This is the only known mass extinction of insects. The planet was devastated so completely that it took 10 million years for biodiversity to recover to previous levels. 10 million years. That's 1,600 times longer than human civilization has existed. What caused this apocalyptic event? The Siberian Traps, a massive volcanic eruption that lasted about 1 million years. Magma burst through Earth's crust across the territory of modern Siberia, covering an area the size of Europe with lava layers up to several kilometers thick. Volcanoes spewed enormous quantities of carbon dioxide, methane, sulfur dioxide into the atmosphere. Greenhouse gases caused runaway warming. Temperatures in the tropics could have reached 60 degrees Celsius, too hot for most animals to survive. Oceans warmed, became acidic, lost oxygen. Marine life suffocated en masse. On land, acid rain destroyed vegetation. Food webs disintegrated. Ecosystems collapsed one after another like falling dominoes. And here's the most chilling part. This wasn't an instantaneous catastrophe like an asteroid impact. It was a slow collapse stretching over hundreds of thousands of years. Species died in waves. Brief recovery periods were replaced by new crises. The biosphere slowly bled out. Now imagine a civilization existing during such an event. They watch their world slowly dying. Temperatures rise year after year. Crop failures follow one another. Rivers dry up. Oceans turn into dead zones. Animals they hunted disappear. Plants they ate perish. They try to adapt. They migrate to cooler regions, toward the poles, into mountains. They change their diet, seek new sources of food and water. Maybe their science is advanced enough to understand what's happening. Maybe they even try to do something. But ultimately, it's too much. The planet is changing too fast, too radically. Even an intelligent species with technology cannot survive when the biosphere itself is collapsing. They go extinct. Maybe not all at once. The last isolated groups cling to life in refuges where conditions are still tolerable. But eventually, they too disappear. And when the crisis finally ends, when the volcanoes quiet and climate begins to stabilize, the planet is empty, ready for a new chapter of evolution. From the civilization that was here, nothing remains. Their cities, if they had them, destroyed by volcanic activity, buried under kilometers of lava and ash. Their bones decomposed, their tools rusted, their technology turned to dust. After a few million years, new life covers the planet, and no one knows they were here. This isn't just speculation for dramatic effect. This is a pattern we see again and again. Mass extinction, then recovery, then a new era of life. It's happened at least 5 times on a large scale and dozens of times on smaller scales. Each time it was the end of one world and the beginning of another. And each time, traces of what came before were almost completely erased. Here's the question that should haunt you. What if some of these extinctions weren't completely natural? What if an intelligent species, having reached sufficient technological level, could alter their planet so dramatically that they caused their own extinction? We know this is possible. We're doing it right now, changing climate faster than it's occurred naturally over the last 10,000 years. CO2 concentration in the atmosphere is now higher than it's been for the last 3 million years. Global temperature is rising, glaciers are melting, sea level is rising, extreme weather events are becoming more frequent and severe. Simultaneously, our activity is causing what biologists call the 6th mass extinction. Species are disappearing 100 to 1,000 times faster than would occur naturally. Over the last 50 years, populations of wild vertebrates have declined by an average of 70%. Insects are becoming fewer. Coral reefs are dying. Forests are being cut down. We're witnessing the beginning of ecological collapse in real time. If we don't change course radically and quickly, within a few centuries or millennia, humanity could face catastrophic consequences. Not necessarily complete extinction, but possibly civilizational collapse, mass human death, a return to primitive existence for those who survive. And what would future geologists see studying our layer millions of years hence? A mass extinction, sharp climate change, a layer with unusual chemical properties, elevated concentrations of carbon, metals, traces of plastic and radioactive isotopes. They might interpret this as a natural catastrophe, maybe a volcanic event, maybe something else. Or, if they're very attentive and know what to look for, they might understand that this was a civilization that destroyed itself. Now flip this logic. When we look at ancient mass extinctions, we automatically search for natural explanations. Volcanoes, asteroids, changes in ocean currents, fluctuations in Earth's orbit. And in most cases, we find these explanations. But can we be absolutely certain that all these events were purely natural? The Paleocene-Eocene thermal maximum, 56 million years ago. Sharp warming, mass extinction, carbon anomalies. Standard explanation: methane release from ocean sediments. But would it look any different if an industrial civilization caused it? No, absolutely identical. The late Devonian extinction, 375 million years ago. About 75% of species disappeared in a series of extinctions stretching over 20 million years. Presumed causes: sea level change, ocean anoxia, possibly volcanism or asteroid impact. But data are fragmented. The exact cause is still debated. Could there have been something else? Something we're not considering because we deem it impossible? I'm not claiming ancient civilizations caused these extinctions. There's no evidence for that. Natural explanations remain most probable.
But I'm saying we cannot exclude this possibility with absolute certainty.
And this uncertainty alone should make us think about our own impact on the planet. Because if it happened before, if an intelligent species destroyed itself by changing climate, it could happen again with us. History doesn't repeat exactly, but it rhymes. And now the rhymes are becoming disturbingly familiar. Let's now examine specific mysteries. Findings that don't quite fit the accepted picture. Anomalies that make you think. I'll immediately stipulate that most so-called mysterious artifacts have simple explanations. The internet is full of pseudo-scientific claims about impossible finds that upon examination turn out to be either forgeries, incorrectly dated, or misinterpreted natural formations. But among this noise are a few things that deserve honest consideration. In 1972, in uranium ore from the Oklo mine in Gabon, Africa, French physicists discovered something impossible. The isotopic composition of uranium was wrong. The ratio of uranium-235 to uranium-238 differed from normal. This could be explained only one way. Someone, or something, used this uranium in a nuclear reaction about 1.7 billion years ago. Conspiracy? Ancient astronauts? No. The explanation turned out to be even more surprising. Oklo is the only known place on Earth where a natural nuclear reaction occurred. About 1.7 billion years ago, several unique conditions converged. High concentration of uranium in ore, presence of groundwater that served as neutron moderator, the right geological structure allowing the reaction to be self-sustaining. For several 100,000 years, a natural nuclear reactor operated in Earth's depths, producing energy and splitting uranium exactly as our atomic power plants do, only without human participation. This shows an important thing. Nature is capable of creating phenomena we consider exclusively technological. Sometimes what looks like a trace of civilization turns out to be just an unusual natural process. But this logic also works in reverse. What if some natural phenomena actually have artificial origins, but we don't see it? Take the strange geoglyphs in Peru's Nazca Desert. Giant lines and figures visible only from the air. Monkey, spider, hummingbird. Geometric patterns stretching for kilometers, created by the Nazca culture between 500 BCE and 500 CE. We know who made them. The Nazca people. We know how. By removing dark stones from the surface, exposing lighter earth beneath. We even roughly understand why. Religious or astronomical purposes, possible connection to water cult. But here's what's interesting. These lines have survived 1,500 to 2,500 years in one of the driest places on Earth. If the climate had been more humid, they would have disappeared within a few centuries under erosion and vegetation. Now imagine similar structures created 10 million years ago, or 50. Even in dry climate, they wouldn't have survived. Wind, rare rains, tectonic activity would have erased them completely. Or take Göbekli Tepe in Turkey. A massive temple complex built about 11,000 years ago by hunter-gatherers, before the invention of agriculture, before the appearance of writing, before everything we consider signs of civilization. Enormous T-shaped stone pillars up to 5.5 meters high, weighing up to 10 tons, decorated with detailed animal carvings. Organizing construction required coordination of hundreds of people. This overturned our understanding of human society development. But Göbekli Tepe survived only because it was intentionally buried by the ancient builders. Without this, erosion and time would have destroyed it. And it dates to only 11,000 years ago, a blink in geological scales. What could have existed millions of years ago that left absolutely nothing behind? There's another category of anomalies worth mentioning. Out-of-place artifacts. Objects not in their proper place. Things that, according to their age and context, shouldn't exist. Most turn out to be forgeries or errors, but not all. In 1900, Greek sponge divers discovered a sunken ship from the 1st century BCE off the island of Antikythera. Among amphorae and statues, they found a strange bronze mechanism covered in corrosion. It looked like a lump of metal, but X-rays showed something astonishing. Inside were dozens of bronze gears of complex construction. The Antikythera mechanism, as it was named, turned out to be an ancient analog computer designed to calculate astronomical positions and predict eclipses. Its level of engineering sophistication had no analogs in the ancient world. Nothing comparable in technical ingenuity appeared again until the 14th century, almost 1400 years later. This doesn't mean ancient Greeks were more advanced than we thought, or that aliens helped them. It simply shows that technological knowledge doesn't develop linearly. There are bursts of genius that are then forgotten. Knowledge is lost during wars, epidemics, cultural collapses. Romans knew how to make concrete that hardened underwater and was stronger than modern concrete. The recipe was lost for more than 1,000 years. Damascus steel was famous for its strength and sharpness, but the technology of its manufacture disappeared in the 15th century and still hasn't been exactly reproduced. History is full of lost technologies, things people knew and then forgot. Now scale this up to millions of years. How many inventions, how many technological breakthroughs could have been made and then lost? How many civilizations could have risen, created amazing things and then disappeared, taking their knowledge into oblivion? Without written records, without continuous transmission of knowledge, everything can be forgotten surprisingly quickly. Imagine all human civilization disappears right now. All people instantly vanish. Libraries remain, books remain, but no one to read them. After how many generations would an intelligent species appearing later forget we existed? If they appear after 10 million years, they'll find absolutely nothing. No books, paper long since rotted. No buildings, most destroyed. No obvious artifacts. Maybe they'll find strange plastic fragments in sedimentary layers, maybe chemical anomalies. But connecting this to a civilization without context, without other evidence, would be almost impossible. Let's now talk about oceans in more detail, because if anywhere is hiding secrets, it's there. Oceans cover 71% of Earth's surface. Average depth about 3.7 kilometers. Water volume in oceans approximately 1.335 billion cubic kilometers. And we've explored less than 5% of this volume. 5%. 95% of the ocean floor has never been seen by human eyes directly. We've made more detailed maps of Mars's surface than our own ocean floors. Why? Because exploring ocean depths is incredibly difficult. Pressure at 4-kilometer depth is about 400 atmospheres, more than 5,800 pounds per square inch. This would crush a human instantly. Even special submarines can dive only to certain depths. There's no light. Absolute darkness below 1,000 meters. Temperature is close to zero, though in some places, hot hydrothermal vents gush from the floor with temperatures up to 400 degrees Celsius. It's an alien world, as inhospitable as another planet's surface. And it covers most of our planet. In these depths, hide things we're only beginning to suspect. In 1977, oceanographers exploring the Galapagos Rift discovered hydrothermal vents, black smokers spewing superheated water saturated with minerals. Near them thrived entire ecosystems based not on photosynthesis, but on chemosynthesis, bacteria obtaining energy from chemicals in hot water. Giant tube worms, up to 2.4 meters long, blind white crabs, strange mollusks, life forms that don't depend on sunlight, living in complete darkness, feeding on energy from Earth's interior. This discovery fundamentally changed our understanding of where life can exist. If life thrives in such extreme conditions on Earth, maybe it exists in subsurface oceans of Jupiter's or Saturn's moons, where sunlight never reaches the surface. But here's what's important for our discussion. We found these ecosystems only in 1977, less than 50 years ago. They existed for millions of years, but we didn't know about them. What else is hiding down there that we still don't know about? In 2013, in the northern part of the Atlantic Ocean, at a depth of about 900 meters, researchers discovered a structure named Lost City, a field of hydrothermal vents, but not of volcanic origin. White towers of calcium carbonate, some up to 60 meters tall, rise from the ocean floor. They emit water with temperatures up to 90 degrees Celsius, alkaline, rich in hydrogen and methane. And this system has existed, by estimates, for 120,000 years, possibly longer. The structures look almost artificial. Straight towers, some with regular geometric forms. Of course, this is a natural formation, the result of specific geochemical processes. But it requires careful investigation to determine this. What if at depths of 3 or 4 kilometers, under kilometers of sediment, lie structures created not by nature, but by intelligent beings millions of years ago? How would we discover them? Sonar mapping provides only a general idea of floor topography. Fine details are lost. Submersible dives explore tiny areas, rarely more than a few square kilometers per expedition. With ocean floor area of about 361 million square kilometers, the chance of accidentally stumbling upon an ancient underwater structure the size of, say, a small city is virtually zero. Moreover, even if such a structure were discovered, its interpretation would be complex. Corrosion, incrustation by marine organisms, deformation from sediment weight, all this would make it almost unrecognizable. In 1985, off the coast of Japan's Yonaguni Island, divers discovered a massive underwater structure. Terraces, steps, right angles, flat surfaces. At first glance, ruins of an ancient city or temple. Some enthusiasts date it to 10,000 years ago, when sea level was lower and this area was land. They claim it's remnants of a lost civilization. Most geologists disagree. They point out that rock in this region is layered sandstone, which naturally fractures along parallel lines due to its crystalline structure. This creates formations that can look artificial. Right angles, flat surfaces, something resembling steps. There are no clear traces of tool working, no artifacts found nearby, no other evidence of human activity in this place at that time. Most likely, it's a natural formation. But most likely doesn't mean definitely. Some researchers suggest a compromise. Perhaps it's a natural formation that ancient people slightly modified, adding steps or carving some surfaces. Without thorough underwater excavation and detailed analysis, we can't know for certain. And such research isn't being conducted because most scientists believe there's nothing to look for. And here's the problem with searching for ancient civilizations. If you're not looking, you won't find. Archaeologists don't search for traces of non-human civilizations because they believe they didn't exist. Geologists interpret anomalies as natural processes because that's the most probable explanation. Paleontologists classify fossils as animal species, not intelligent beings, because there's no context indicating intelligence. This isn't conspiracy, it's simply how science works. We start with the simplest explanations and move to more complex ones, only if simple ones don't work. This is called Occam's razor, and in most cases, it's the right approach. The simple explanation is usually correct, but usually doesn't mean always. Sometimes reality turns out more complex than the simplest explanation. And if we automatically dismiss the possibility of something unusual, we risk missing the truth. Let's return to the question of intelligence. What makes a being intelligent? How do we recognize intellect? Humans have a tendency to define intelligence through the lens of our own experience. We value abstract thinking, language, tool use, ability to plan for the future, self-awareness. But this is an anthropocentric approach. Intelligence can manifest differently. Take octopuses. Their intelligence is radically different from ours. They don't have a centralized brain in our understanding. 2/3 of their neurons are in their tentacles, which can make decisions independently of the head brain. They solve complex problems, open jars with screw-top lids, navigate mazes, recognize individual humans. They use tools, carrying coconut shell halves as portable shelters. They're masters of camouflage, able to change skin color and texture in a fraction of a second. Some octopus species even demonstrate rudiments of culture. In Jervis Bay, Australia, an underwater octopus settlement was discovered, named Octlantis. About 15 individuals live in close proximity, interact with each other, build shelters from shells and stones. This is unusual because most octopuses are solitary. But in Octlantis, they formed something resembling a community. Are octopuses intelligent? Depends on the definition. They don't have language in our understanding. They don't build structures. They live only 1 to 2 years. Too short a lifespan for transmitting complex knowledge through generations. But they have complex consciousness. They're aware of their surroundings, make choices, adapt to new situations. This is a form of intelligence, just different. Now imagine a cephalopod species that evolved for millions of years toward greater intelligence. Larger brain size, longer lifespan, social behavior. What could result? An oceanic civilization we've already discussed, unlike ours, but still a civilization. And it would be almost invisible in the geological record. Or consider ravens and their relatives. They demonstrate amazing cognitive abilities. New Caledonian crows manufacture complex tools, using specifically shaped sticks to extract insects from tree bark. They transmit these techniques through social learning. Ravens can plan for the future. In experiments, they set aside food for later, demonstrating understanding of the concept of future time. They recognize human faces and remember those who posed threats for years. Some show self-awareness. When a bird is marked with paint and placed before a mirror, some individuals understand they're seeing themselves and try to remove the mark. Birds evolved separately from mammals over 300 million years ago. Their brains are structured completely differently. They lack neocortex, the part of mammalian brain responsible for higher cognitive functions. And yet, they've developed comparable intelligence using different neural architecture. This shows that evolution can arrive at the same result through different paths. If birds did this over 300 million years of evolution, why couldn't dinosaurs, who ruled for 165 million years, develop similar or greater intelligence? Modern birds are dinosaurs. Literally. They descended from small theropods that survived the Cretaceous-Paleogene extinction. If their descendants can be so intelligent, their ancestors had the potential too. Now let's talk about something completely different: time and memory. Nearly every human culture has myths about previous worlds, about civilizations existing before us. Greek mythology describes 5 ages of humanity. The Golden Age, when people lived like gods without toil or suffering. The Silver Age, when seasons appeared and work became necessary. The Bronze Age of war and violence. The Age of heroes, demigods and great warriors. And finally, the Iron Age, our time, an era of decline and suffering. In Hindu cosmology, time is cyclical. 4 yugas repeat in an endless cycle. Satya Yuga, the golden age lasting 1,728,000 years. Treta Yuga, 1,296,000 years. Dvapara Yuga, 864,000 years. And Kali Yuga, the age of darkness, 432,000 years, in which we supposedly now find ourselves. A complete cycle called Mahayuga lasts 4,320,000 years. After it, the world is destroyed and recreated anew. The specific numbers are mythological, of course, but the concept is interesting. Cyclical time, repeating epochs, the rise and fall of worlds. Many indigenous American cultures tell of several worlds existing before the current one. The Hopi speak of 4 worlds, 3 of which were destroyed due to human wickedness. The Navajo also describe 4 previous worlds. The Aztecs believed in 5 suns, 5 eras of creation. Each sun represented a world with different inhabitants. The first sun was destroyed by jaguars, the second by hurricanes, the third by fiery rain, the fourth by flood. We live under the 5th sun, which according to prophecy will be destroyed by earthquakes. Mesopotamian texts mention kings ruling before the Great Flood with incredible reign lengths, tens of thousands of years. After the flood, reign lengths become more realistic. Plato in dialogues Timaeus and Critias describes Atlantis, a great civilization existing 9,000 years before his time, destroyed by cataclysm in one day and night. Most historians consider Atlantis fiction, Plato's philosophical allegory about ideal society and the danger of hubris. No archaeological evidence of its existence has been found. But it's interesting that similar stories of lost civilizations appear independently in cultures worldwide. Mu in the Pacific Ocean, Lemuria in the Indian Ocean, Hyperborea in the far north. What should we make of these myths? The scientific approach says, don't take them literally. They're full of supernatural elements, gods, magic, impossible events. They reflect cultural values and fears, not historical facts. But perhaps they preserve some distorted memory of real events. Not of ancient advanced civilizations, but of climate catastrophes, of times when the world was radically different. The Great Flood, mentioned in multiple cultures from Mesopotamia to Australia, could be an echo of a real event. About 11 to 12,000 years ago, the last ice age ended. Glaciers melted. Sea level rose by 120 meters. Coastal plains where people lived were flooded. For people of that time, this would have been an apocalyptic event. Entire regions disappeared underwater. Stories about this were transmitted orally through generations, transforming, accumulating mythological details, but preserving a kernel of truth. Maybe myths about previous worlds work similarly. Not literal stories about ancient civilizations, but cultural memory that the world is changeable, that there were times before that ended in catastrophe, that we're not the first to live here. This is a deeper intuition than specific facts, a feeling people have always had that the planet is older than us, that other things were here before, that our time is temporary. And this intuition is correct, even if myth details are invented. Earth is older than us. Other beings truly were here before, billions of years of life before the first human. Our time truly is temporary. Eventually we'll disappear, as all species before us disappeared. Myths express these truths metaphorically. And maybe there's wisdom in this. Wisdom not in specific details, but in the general message. Be humble. The world is bigger than you. History is longer than your memory. Now let's consider another angle. What do physics and astronomy say about the possibility of ancient civilizations? There's a concept called the Fermi paradox. Enrico Fermi, a physicist who worked on the Manhattan Project, was discussing UFOs and the probability of alien life with colleagues over lunch in 1950. Suddenly he asked, "Where is everybody?" His logic was simple. The Milky Way contains 100 to 400 billion stars. Many have planets. Some of these planets are in the habitable zone, at the right distance from their star to have liquid water. If even a tiny fraction of these planets developed life, and a tiny fraction of that life became intelligent, millions of civilizations should exist in the galaxy. Some of these civilizations should be millions or billions of years older than us. If they developed space travel, even at sublight speeds, they could colonize the entire galaxy in a few tens of millions of years. A tiny period on cosmic scales. So, where are their ships? Where are their signals? Where are their artifacts in our solar system? We see nothing. The sky is silent. This is the Fermi paradox. Many solutions have been proposed. Maybe interstellar travel is impossible or impractical. Maybe intelligent life is incredibly rare. Maybe civilizations destroy themselves soon after reaching technological level. Maybe they intentionally don't contact us. The zoo hypothesis. Maybe they're here but we don't recognize their presence. But there's another solution especially relevant for our discussion. Maybe civilizations exist very briefly by cosmic standards. Think about our own civilization. We've been broadcasting radio signals into space for only about 100 years, since radio's invention in the late 19th century. That's the window during which a distant civilization could accidentally intercept our transmissions. How much longer will we broadcast? Maybe a few hundred years before we either destroy ourselves or switch to directed communications that don't leak as much into space. Say, 1,000 years of detectability. That's 0.002% of Earth's age. A tiny window. If this is typical for civilizations, if they're usually detectable only during a very short period of their existence, the probability that two civilizations will be detectable simultaneously becomes very small. The galaxy could be full of planets that had civilizations in the past, or will have them in the future. But the chance that two civilizations exist in detectable states simultaneously is low. This is sometimes called the "they were but not now" solution. And if this is true on a galactic scale, why not on one planet? Why couldn't Earth have its own "they were but not now"? Civilizations are ephemeral. They rise and fall. This could be a universal pattern, not an exception. And here's what this means for us. We're not evolution's pinnacle. We're not the end point. We're simply the current iteration in nature's ongoing experiment in creating complexity. If we disappear through our foolishness or bad luck, life will continue. It always continues. After a few million years, another branch of evolution might create another form of intelligence, another civilization, and they won't know about us, just as we don't know about those who possibly came before us. This is a cycle, not a vicious circle, but a spiral, each iteration slightly different. Evolution experiments with different solutions. Sometimes the experiment is successful and lasts long. Sometimes it ends quickly, but the experiment continues. And there's strange comfort in this. If we're not the first and not the last, we're part of something larger, a pattern that transcends any individual civilization. Intelligence isn't an anomaly, not an accident, not a unique event. It's what the universe does under the right conditions. Organizes matter into patterns that can think, feel, be aware of themselves. This sense of recognizing our own insignificance can be simultaneously frightening and liberating. Frightening because our ego wants to believe we're special, unique, the crown of creation. Liberating because if we don't bear responsibility for all existence, if we're simply part of the flow, then we can relax, accept our temporality. But this doesn't mean we don't matter. Every life matters. Every moment of consciousness is precious. Not because we're eternal, but precisely because we're not eternal. Right now we exist. Right now, in this moment, we're here. We think, feel, are aware. And that's a miracle, even if it's temporary, especially because it's temporary. So what can we say with certainty about the possibility of ancient civilizations? We can say the geological record is incomplete, that time destroys almost everything, that our methods for detecting civilization in the deep past are limited, that evolution experiments with intelligence again and again, that conditions for developing intelligence existed long before humans. Can we say an ancient non-human civilization definitely existed? No. There's no evidence.
Can we say it definitely didn't exist?
Also no. We cannot exclude it. And in this space of uncertainty, between impossible and proven, lives one of the most intriguing possibilities in science. Let's dig even deeper into specific cases that make us wonder. Not pseudoscientific fantasies, but real scientific puzzles that still lack full explanation. In South Africa, there's a place called Klerksdorp. Miners there extract pyrophyllite, a soft metamorphic mineral. And sometimes in this rock they find strange spheres, metallic balls, sometimes with 3 parallel grooves encircling the equator, about the size of a golf ball, some hollow, filled with spongy white material, others solid, composed of nickel and iron alloy. Here's what makes them strange. The rock they're found in dates to approximately 2.8 billion years ago. That's long before any complex life on Earth, let alone intelligent beings. Creationists and alternative history enthusiasts quickly declared this proof of ancient civilizations, or even alien intervention. Metallic spheres with perfect grooves in rock nearly 3 billion years old. This can't be natural, they say. But geologists have a different explanation. These spheres are most likely concretions, mineral formations that form naturally when minerals precipitate around a nucleus in sedimentary rocks. The process is called accretion. The grooves might result from cracks in the rock or zones of different mineralization that weather differently, creating parallel depressions. The metallic composition could be meteoric iron or natural deposits formed under the right chemical conditions. This is a rational explanation based on known geological processes, without needing to invoke extraordinary claims about ancient civilizations. But here's what's interesting. No one has conducted truly thorough research on these spheres using modern analytical methods. Most studies were superficial. The spheres sit in museums as geological curiosities, but detailed analysis of their internal structure, precise chemical composition, groove formation, hasn't been published in serious scientific journals. Why? Because most scientists are already convinced they're natural formations and see no point spending time and resources on detailed study. And maybe they're right. Most likely right. But what if not? What if there's a 1% chance these spheres were actually created by an unknown process we don't understand? Not necessarily by aliens or ancient civilizations, just something our current geological theory doesn't account for. We'll never know if we don't investigate. Here's another mystery, more recent and stranger. In 2001, oceanographers surveyed waters off Cuba's coast using deep-sea sonar. At a depth of about 700 meters, they discovered something unexpected. Geometric structures. Symmetrical, with straight lines and right angles. Something that looked like pyramids, rectangular buildings connected by what resembled roads. The team, led by engineer Paulina Zalitsky, was stunned. They conducted several additional scans. Results were consistent. The structures were there. In 2002, they sent down an underwater vehicle with cameras. The video was grainy. Water at such depths is murky, lighting difficult. But it showed large blocks of stone. Some appeared worked, with smooth surfaces and regular shapes. Zalitsky suggested these might be remains of an ancient city that sank into the sea thousands of years ago, possibly connected to Atlantis legends. But here's the problem. If these structures are man-made, they must have been built when this region was land. Geological data shows sea level was low enough for this only during the last glacial maximum, about 20,000 years ago. But even then, this area wasn't land at 700 meters depth. Maximum sea level drop was about 120 meters, not 700. For this place to be land, you'd need to go back tens of millions of years. But humans didn't exist then. So what is it? Most geologists who've reviewed the data believe these are natural geological formations, perhaps the result of tectonic activity or unusual erosion processes that created structures resembling artificial ones. Nature sometimes creates surprisingly regular forms. Basalt columns. Giant's Causeway in Ireland looks like perfectly carved hexagonal pillars, but results from cooling lava. Costa Rica's stone spheres are nearly perfectly round, but formed naturally through concretion processes. Perhaps the Cuban structures are a similar case. But without thorough underwater excavation, without retrieving stone samples for analysis, without detailed mapping of the entire area, we can't say for certain. And here's what's frustrating. Since 2002, there's been virtually no additional research. Expeditions to such depths are expensive. The Cuban government hasn't allocated funding. International scientific organizations were skeptical of the claims and didn't support the project. So the mystery remains unsolved. On the Caribbean seafloor, at 700 meters depth, lies something we don't fully understand, and no one's actively trying to figure it out. Maybe it really is just rocks. Maybe nature's playing with us, creating illusions of order in chaos. But maybe not. Now let's talk about something entirely different, but related. Intelligence in unexpected places. We tend to think of intelligence as something requiring a brain. Neurons, synapses, electrical impulses. The more neurons, the smarter the being. This makes sense for animals we know. But recent research shows this is a limited view. Take slime molds. They're not fungi, though often called that.
They're amoeboid organisms that spend part of their life as single cells and part as a multicellular mass crawling across forest floors.
They have no brain, no nervous system, no organs at all. Literally, a mass of cytoplasm with thousands of nuclei surrounded by a membrane. And yet, they solve complex problems. In experiments, the slime mold Physarum polycephalum was placed on a maze map with food sources at different points. The organism explored all paths, then optimized its structure, forming shortest connections between food sources, removing inefficient branches. Essentially, it solved the shortest path problem, a task requiring computation for computers. Japanese researchers went further. They created a map of the Tokyo region, placing oat flakes as food sources at major city locations. The slime mold, starting from Tokyo's position, spread out and formed a network strikingly similar to the region's actual rail network. Efficient, redundant, optimized. Engineers spent decades designing that network. The slime mold recreated it in 26 hours. How? Through simple local rules. Each part of the organism responds to chemical gradients, food presence, thickness of neighboring branches. No central planning, no conscious thought. Yet, intelligent behavior emerges. This is called distributed intelligence. Intelligence without a brain. Problem solving through distributed processes rather than centralized thinking. And it makes you wonder what else we don't recognize as intelligent simply because it doesn't look like our type of intelligence. Trees communicate with each other. Their roots connect with fungal networks, mycorrhiza, transmitting nutrients and chemical signals between trees. A mother tree can recognize her offspring and send them more resources. When a tree is attacked by insects, it sends signals through the mycorrhizal network, warning neighboring trees, which then begin producing defensive chemicals. Is this intelligence? Depends how you define the term. It's not consciousness in our understanding, but it's adaptive, communicative behavior. It's information processing. Maybe intelligence isn't a thing, but a continuum. From simple chemical reactions to bacteria responding to environment, to slime molds solving mazes, to insects with their complex social structures, to birds and mammals, to us. And if it's a continuum, where do we draw the line? When does something become intelligent in a meaningful sense? And here's the key question for our discussion. Could evolution have experimented with completely different types of intelligence in the past? Not necessarily a brain and a skull, maybe a distributed nervous system throughout the body. Maybe collective intelligence of a colony, where individual organisms are simple, but together form something smart. Ant behavior demonstrates this perfectly. A single ant is stupid. It follows simple rules. Follow the pheromone trail, pick up food, attack threats. But a colony of millions of ants behaves like a single superorganism, with collective decision-making, division of labor, ability to adapt to new situations. Some leafcutter ant species practice agriculture, growing fungi in underground chambers. They cut leaves, chew them into paste, use it as substrate for fungi they eat. They even use bacteria to produce antibiotics, protecting their fungal farms from pathogens. This is a primitive form of agriculture and biotechnology that evolved 50 million years ago, long before humans. Now, imagine a larger organism or larger colony, billions instead of millions of individuals, more complex communication, longer colony lifespan. What could result? A collective intelligence we wouldn't recognize as civilization because it doesn't build buildings or write books, but which nevertheless possesses knowledge, makes decisions, purposefully alters its environment. And if such a thing existed millions of years ago, what traces would it leave? Perhaps changes in distribution of certain plants, anomalous mineral concentrations in soil in specific regions, unusual chemical compounds we can't explain. We find such anomalies and usually attribute them to natural processes, maybe correctly, but maybe sometimes we're missing something stranger. The universe is full of mysteries we're only beginning to understand. Every answer we find raises 10 new questions. And that's beautiful. That's what drives us forward. The endless quest to know more, to understand deeper, to see further. So, were there ancient civilizations on Earth before us? Honestly, we don't know. Maybe they were here, maybe not. The evidence is ambiguous, the timescales are vast, the methods imperfect. But the very fact we can ask this question, that we can imagine other forms of intelligence across deep time, shows something profound about who we are. We're the species that looks back across billions of years and wonders. We're the ones who dig in stone seeking answers. We're the curious ones, the questioners, the dreamers who refuse to accept that what we see is all there is. And maybe that's the most important thing. Not the answers we find, but the questions we dare to ask. Because in asking these questions, we acknowledge our place in a story far larger than ourselves. A story that began long before us and will continue long after we're gone. We're one chapter in an epic that spans the age of the earth itself. And what a privilege it is to be here, now, aware enough to wonder about it all. The cosmos organized matter into patterns that could think, and now those patterns look back at the cosmos and ask, what else have you created? Who else has wondered? Who else has dreamed beneath these same stars? We may never know all the answers. Time has hidden them too well, but we'll keep searching, keep questioning, keep reaching beyond what we know toward what we might discover. Because that's what intelligence does. It seeks, it wonders, it reaches for truth even when truth is elusive. And perhaps, millions of years from now, another intelligence will stand where we stood and ask the same questions about us. They'll dig through the layers of stone and wonder if we were here. They'll debate whether the faint chemical traces they find could indicate a lost civilization. And maybe, just maybe, they'll conclude what we're concluding now. The earth is old. Life is persistent. Intelligence arises and fades like waves on an endless shore. We're all temporary custodians of consciousness, brief sparks in the long darkness. But while we burn bright. We ask, we wonder, we seek to understand, and that makes all the difference. And that makes all the difference. So tonight, as you close your eyes, remember this. You're part of something ancient and ongoing, a pattern that's repeated across unimaginable spans of time. Intelligence emerging, wondering, seeking, then fading back into the stone from which it came. But while you're here, you matter. Your questions matter. Your wonder at the universe matters. Because consciousness, wherever and whenever it arises, is the universe looking at itself with amazement. Sleep well. Let your dreams wander through deep time, through possibilities we haven't yet imagined, through the mystery of all that came before and all that might come after. Good night. And remember, the greatest discovery isn't finding answers. It's having the courage to keep asking questions.